measure phase. And then in the afternoon, we'll proceed with the analyze. Analyze might continue tomorrow morning also. And then the improve and control, fairly easier part of the DMAT methodology that we will be able to conclude tomorrow afternoon. So that is the plan. So in define phase, our goal is to thoroughly understand the problem, understand the scope, understand the boundary, and having a proper metric to measure the problem, right? So everything is made very, very clear, and then sponsor is convinced. Now we are in the measure phase. Now the primary goal is to validate the problem with the data and then measure the baseline value of the metric. Baseline means the ground reality. Where are we currently right now with respect to the target? Your project might be reducing the rejections. If your project is reducing the rejection, what is exactly the current rejection rate? You should have a correct answer for that question. Suppose if your project is reducing the turnaround time in a particular process, then what exactly is the current turnaround time? Right? So this is what we call it as baseline performance. So baseline performance can be measured directly. I mean, you can measure the rejection rate directly. You can measure the turnaround time directly. You can measure the hardness of the material directly, or you can also measure it indirectly. Measuring indirectly, we have certain tools. One of the tools we already learned is DPMO. Why rejections are happening? Because defects are happening, so rejection is happening. So how many defects are happening? Can you somehow measure the defect rate or defect frequency? DPMO is one such metric, or PPM is other metric. Similarly, you can think of calculating process capability indices. Today you will be learning CP and CPK. You can also calculate the yield, first pass yield or the throughput yield, whatever. So these are all indirect way of measuring the baseline performance. And but before measuring the baseline performance, you have to be very, very sure that your data is worthy enough, right? Your data is free from the error. So you need to have a proper data collection plan. A properly planned data collection procedure can minimize the sampling error. Properly planned data collection procedure can minimize the sampling error. Once that is done, you should also ensure you have a proper measurement system in place. So that is going to be today's talk. What is the guarantee that we have a proper measurement system in place so that our data cannot mislead us? Data can actually give the clear picture of the problem. Whatever baseline you calculate, that will be the accurate estimate. All right. So our measurement system should be capable enough. So first of all, what is a measurement system? A measurement system means all the elements that is part of your system that can help you to collect the data. Tell me, what are the elements that you need to collect the data? Do you need a data collector? Definitely, right? So we call him as appraiser or a data collector. Then we need a measuring instrument. We definitely need a measuring instrument. Then we need to have the product, because from the product only we measure. Yes or no? Or no? The characteristics that we need to measure, that is another. See, certain characteristics are easy to measure. Certain characteristics are difficult to measure. Isn't it? So this will definitely affect your accuracy. All right. So then the kind of instructions that are given to the data collector. You are giving him the instruction, right? Those instructions are known as operational definition. You have discussed already. So by reading the operational definition, one should be able to collect the data in an accurate manner. Okay. And finally, the environment under which the data must be collected. That is also an element. So all these elements put together is known as measurement system. So there is a higher chance that any of these elements can pull down your accuracy. Hope all of you agree with me. Any of these elements can pull down your accuracy. So achieving 100% accuracy is really a difficult job. So that's the reason why we go for a frequent calibration of the measuring instrument. That's the reason why we train our data collectors on data collection procedure, right? And that's also the reason why we store our measuring instrument in a proper environment. All of these things are needed only to ensure we get uh, data with the highest level of accuracy. All right. And now when you want to understand the accuracy, there are two things comes into picture. All these elements must be used in a proper manner every single time the measurement system is used so that you can make your data accurate enough. Hope all of you understand what I'm speaking right now. You need to ensure all these elements, are used in a proper manner. Suppose if data must be collected, let's say the length of a product must be measured, then operational definition, the operator, the environment under which you are measuring, the instrument you are using, everything has to be, uh, uniform. Every single time you measure the length, you can't say, sir, the morning data collection was made by operator X and now it is operator Y. And that's the reason that's why, there is a lag in the accuracy. You can't have that excuse. So what I'm trying to say here is there has to be consistency in the measurement, first of all. Whether you measuring the data or you collecting the data or me collecting the data or someone else is collecting the data, first of all, there has to be consistency, right? There can be, you might use vernier caliper to measure the length. There are 10 vernier calipers in your workplace. People might use any of the 10 vernier caliper and then measure. And now, how are you going to bring the consistency in the measurement? All the vernier caliper should be in the same, condition. Yes or no? If any particular vernier caliper is, let's say, is not calibrated or it's in a bad condition, then what will happen? All the readings that are coming from that particular vernier caliper will have problem, and that will affect your overall accuracy. So before accuracy, what you need to ensure is consistency. All of you agree with me? If you can't ensure consistency, then accuracy will be a big question mark in such environment. If there is no consistency, almost there won't be any accuracy. Places where consistency is lagging, they will definitely lag in terms of accuracy. Is my statement correct? Okay. So the first part is to achieve the consistency. So just now we understood consistency means if a procedure is repeated multiple times, the result has to be same. That's called consistency. Suppose if you are asked to collect the data, and if you have to repeat your own data collection, then you should be able to repeat your readings also. Yes or no? If I ask you to collect the length of a particular product 3 times, it's the same product, it's the same instrument, it's the same appraiser collecting the data 3 times back to back or with some time interval. What should be the outcome? All the 3 readings must be same. All the 3 readings must be same. This is known as repeatability of the measurement system. This is known as repeatability of the measurement system. Hope everyone is clear with this.
Yes, sir.
Same measurement system used to measure the same characteristics multiple times and the result is same. This is known as repeatability of the measurement system. Very, very important characteristics of any measurement system. If you're talking about accuracy, this is a prerequisite. If you want to construct a building, then foundation is the prerequisite. Without foundation, you can't construct a building. Same manner, if there is no consistency and you talking about accuracy is a meaningless discussion. So this has to be understood. So repeatability of the measurement system is an important requirement so that you can build the accuracy slowly. You can advise people, you can improve on the measurement system, you can calibrate your measurement system. All that can take your readings closer to the true value. But if you lag in terms of repeatability, all your efforts can go in vain. You might calibrate, but still your readings are inaccurate. You might train your people, still your readings can be inaccurate. So make sure you have a measurement system which has a good repeatability. Point number one. And point number two, sometimes you might use multiple appraiser. You might use multiple measuring instrument for measuring the same characteristics. Like for example, mixed X and mixed Y. Both are involved in data collection. Both of them are measuring the length of the product. Same product, same length, but two people involved. Can you see two measurement system in place right now?
Yes, sir.
How many measurement system are working right now? Two measurement system. Now the readings that are coming from measurement system 1 and the readings that are coming from measurement system 2 should match each other. Because you are measuring the same thing. Only thing is you have to involve two different measurement system. If they are matching, that is known as reproducibility. That is known as reproducibility. It's not just two. Sometimes you may go for three appraiser. Three appraiser, automatically three instrument. But what are they doing? All of them are measuring the same characteristics from the same product. Now, if they give the exact readings, this is known as reproducibility. All of you understand the difference between repeatability and reproducibility. Suppose if I ask Chandrasekhar to measure length of a product 5 times and he gets me 5 readings, all the readings are exactly same. Now my question is Chandrasekhar repeatable? Is Chandrasekhar repeatable? No,
Yes, sir.
repeatable now. He gets 5 readings, all same. Why all readings are same? Because he measured the same thing repeatedly. So that means I have a good data collector with me. I could assess his ability to get me consistent reading. Consistency, there is no problem. And now the same product. Now I ask Ishwar to collect the data. Same product, same length. Now Ishwar gets me 5 readings, exactly same. Now please tell me, is that Ishwar also repeatable now?
Yes, sir.
He is also repeatable. And now I have to do one more thing. Since both of them measured the data from the same product, same characteristics, Chandrasekhar's reading and Ishwar's reading should match each other. So that I can say the system is reproducible also. The system has to be repeatable. The system has to be reproducible. If this is not happening, there itself you can understand there is a portion of error that is getting accumulated in your data. One source of error is inconsistency in the measurement. All of you understand? There are two types of inconsistency. One is repeatability error. When I say inconsistency, I add the letters I and N. When I say inconsistency, it means an error. What we need is consistency. So repeatability error. Similarly, another form of inconsistency in the reading is reproducibility error. When I combine them, I mean the repeatability error and the reproducibility error, somehow if I estimate and combine them, then the error can be called as precision error. And the error can be called as precision error. That means the another meaning of the word precision is consistency. Most of the time we say we need precise measurement. Precision is different from accuracy. Precision means we need consistent reading. Accuracy means we want to know the true value. That is accuracy. We'll move on to the accuracy in the next part. Right now we are talking about the consistency. If there is a problem with the consistency, hereafter we will call it as precision error. All of you understand the meaning of what is precision error? Precision error has two components. One is repeatability error. The other one is reproducibility. The sum of the two is precision error. This must be estimated first. Why do I say estimated? Because you can't, actually calculate the error exactly. It can only be estimated. By simulating the data collection, you can only estimate. Before collecting the data, you have to estimate, right? So it's an estimated value. So the summation of repeatability error and reproducibility error must be calculated. Imagine the value is available. Imagine the value is available. Now you have to compare how much is this quantum with respect to our range of data collection. Now you need to understand what will be your range of data collection. What is the characteristics you are measuring? You are measuring length. What is the customer requirement? There is a target value for the length. Let's say the target is 100 mm. And customer would have given you the tolerance plus or minus 0.5. Now, what is the lowest value expected? 99.5. The highest value expected is 100.5. When the customer requirement is 100 plus or minus 0.5, and you developing a process that can produce parts outside this range is not a good idea, isn't it? So you will definitely develop a process that will try to produce parts within 99.5 and 100.5. So the range of your reading is 99.5 and 100.5. 99.5 is your lower spec. 100.5 is your upper spec. Now, do you understand the range of the readings? This is also known as customer tolerance. This is also known as customer tolerance. So your precision error must be compared against the tolerance provided by the customer. First, you must calculate precision error. Then you must compare how much it is in comparison to the customer provided tolerance. So now you are getting a ratio. The numerator component is precision error. The denominator component is tolerance. Precision, tolerance. The ratio is known as precision tolerance ratio. The ratio is known as precision tolerance ratio. The another name of precision tolerance ratio is Gage R&R. Another name of precision tolerance ratio is Gage R&R, where R&R stands for repeatability and reproducibility error. When we talk about Gage R&R, we are actually talking about the error due to inconsistency in the measurement system. When we talk about Gage R&R, we're actually talking about the error due to the inconsistency of the measurement system. We expect this error to be lesser than 10% of the tolerance provided by the customer. We expect this error, it's an industry standard given by AG. If it is lower than that, then it is much appreciated, most welcome. But in any case, it should not be more than 10%. Now, let us try to understand this 10%. Customer tolerance. Upper spec 100.5, lower spec 99.5. So what is the tolerance available? Upper spec minus lower spec, 100.5 minus 99.5 is 1 unit. If the measuring unit is millimeter, then the total tolerance given by the customer is 1 millimeter. Now the rule says, AIAG guideline says, Gage R&R must be less than 10%. Gage R&R must be less than 10%. Now tell me, what is 10% of 1 mm? 0.1 mm. 10% of 1 mm is 0.1 mm. So, the maximum amount of error, any data point in your collected data can have a maximum error of how much? 0.1 mm only. That is the permissible level. Anybody at any point of time, if they collect the data, if they bring data with more than 0.1 error in it, then that data must be eliminated. Then data should not be, included in your analysis.
Sorry, sir. Repeat again, sir. Sorry.
If any data that is collected during your data collection procedure, if it has an error of more than 0.1 mm, then it is unacceptable. Or the moment you understand such things are happening, then you have to think about improving your measurement system and then go for a fresh collection of data. That means you have to scrap your collected data and recollect the complete data after improving your measurement system. The point here is the precision error of more than 10% is unacceptable. But the precision error of less than 10% is acceptable normally. According the guideline is given by AIAG, the Automotive Industry Action Group. All right. So less than 10% is the preferred value for the gauge R&R. And now how can we actually calculate? The calculation procedure, is little laborious. First of all, you have to simulate data collection. You have to simulate, not the actual data collection. You simulate. Simulate means you just, go for a trial data collection. And now trial data collection, you have to now select parts within the, within the limits given by the customer. Customer has given the limit, LSL and USL. In this limit, can you select some sample parts? Possible. You can select some sample parts, isn't it? Sample parts need not be a standard part. It's just a sample part. In that range, you have to select minimum 10 parts. Minimum 10 parts. Out of which 5 should be on the left side of the target value. 5 should be on the right side of the target value. All of you, do you understand what I'm speaking? See, this much thinking and planning and is, data collection during data collection is essential, if you want your decisions to be perfect enough. If you're okay with making any kind of decision with any nonsense data, then you don't have to think all of this. But if you think, oh, even a small bias is can make your decision go wrong, then you have to consider all of this. Yes, Saravanan, you want to ask something? Yeah, please.
Yes, sir. Sir, you explained about the simulations. That's how we got it. It is a collection of data points, and you gave the reference of lower values. I mean, precision values 99.5, and the tolerance value is 100.5. And you are
That is
recommending
upper specification limit.
upper,
This is
yeah,
lower limit is 99.5, up lower spec,
upper.
100.5 is upper spec.
Perfect. So again, like you are recommending a data collection should be 5 points, maybe 10 numbers, minimum 10 sampling. The minimum threshold we kept as a 99.5. You are saying below the 99.5, 5 samples, above the 100.5,
Not
above.
below, not below. Target is 100.
Okay.
Between 100 and the lower spec, you have to select 5 sample. And target and upper spec, you have to take another 5 sample. You see, I'm just guiding you based on the property of normal distribution. Normal distribution is symmetrical about the center. That's the guideline, right? So you have to select in that manner and see whether the same thing is happening in your data also.
Correct, sir.
If the same thing is happening in your data, people are collecting the data, in a proper manner. If after data collection, all the 10 appears on the left side, what does it, you can understand what's happening with your data collection, isn't it? People are not following the procedure.
Correct, sir.
If they don't follow the procedure, the consistency will get affected. But how do we know the consistency is getting affected or not? By looking at the clustering of the data. If the data clusters on just one side, then there is a problem with the consistency. If they divide exactly into 2 parts, now there is a guarantee, isn't it? You get an assurance that people are following the procedure. Likewise, we build so many conditions, but not a common man cannot know all of this.
Correct.
But we set all these things and check whether all these, requirements are met in your data. If the requirements are getting met, then you have a consistent data. Your people are really sincere. They're following the procedure, and your instrument is also, not playing much. Everything goes well. Then only you see consistency in the reading.
Right, sir.
So first point. First point is 50% of the data on the left side, 50% on the right side. Clear, all of you? And then
Sure.
you have to select data collectors or the appraisers. There are only 3 people who normally collect data. Now you can have all 3 of them participating in your trial data collection. If there are 100 people involved in data collection, you can't have all 100 people in your trial study, but then it will be a very tedious and complex study. So you have to randomly select 3 out of the 10. Sorry, 3 out of 10 or 100, whatever. Do you understand? And you should not be biased here. You should not be biased. Don't just, bring the best person for data collection. Don't just put the worst person in the data collection. No. Even you should not know whom you are picking. In that way, you have to pick. Do you understand? All 100 people name, you put it in a box. Now select 3 names. These 3 should participate in your trial data collection. All of you understand what I'm telling? See, why all these guidelines? These are all, very simple things only we normally follow. Even in your childhood days, you must have played all these games. Whenever you want to remain unbiased, you do this. Isn't it? Because if you are also biased, then you checking the consistency, there is no point. So you have to have 10 sample parts, maybe 3 appraisers, in certain cases, 2 appraisers. And no, let's talk in terms of 3. There are 3 appraisers, 10 parts. And now, in order to understand why we have 3, we want to understand whether they are agreeing to each other. If they agree to each other, then reproducibility will be better. If they agree to each other, then reproducibility is better. And over and above, you need to understand whether each of the appraiser has the repeatability or has the ability to repeat their own readings. So in order to test the repeatability, you must make each of the appraiser collect each data at least 2 or 3 times. Every single person should measure every single part at least 2 times or 3 times. Why 2 or 3? Why not 1? If you make them collect only once, you will not be able to judge on their repeatability. Yes or no? Morning, they will collect the data in particular manner. Afternoon, they might collect the data in some other manner. Before lunch, they collect data in particular manner. After lunch, they collect data in some other manner. That brings a problem in our data. So you have to check the repeatability. So you have to make the person collect the data, same data at least twice. This is known as replication. Sometimes replication can be 2, sometimes replication can be 3. All right. Why are we replicating? Because we want to understand the repeatability in the measurement system. If we don't replicate, we can't get an estimate of repeatability error. Yes, Satish Kumar, you are raising your hand. Please go ahead with your question.
Yes, sir. Sir, if I randomly pick the people, in that people, the newcomers are, they don't measure as much as the experienced person. I will get a abrasor error, sir. So
Yeah,
the
you're
method
right.
is right or not? Why? Because
First of
regularly
all,
we are
first
doing.
of all, the idea is to bring consistency in your readings.
Yes, sir.
And you can't have reasons. Sir, certain people are newcomers and certain people are experienced. And so there will be inconsistency. If you are admitting inconsistency, it means you are admitting error.
Yes, sir.
Yes or
But
no?
the method of people selection, is that right? That is my question, sir. Why?
No.
Because
Sir, can I come?
uh,
You have to be unbiased. You have to be unbiased in any scenario. At the same time, all your data collectors should have the ability to collect accurate reading. Otherwise, they should not be called as data collectors. You can't say some people are fresh, so they don't know the procedure, they don't know how to handle the measurement system, but I will still use them in my data collection. That's a wrong approach, right? If you know they are fresh, and separate them. If you know someone who is fresh but good at data collection, include him. Do you get my point?
yes, sir.
You can't say I will have problems, around me and then I should be risk free. No, you should be under the risk of, facing all the problems if you keep problems around you. All right.
Okay. Okay, sir.
RK sir, you want to add
Yeah.
something?
Uh, Satish Kumar,
Yes, sir.
I would like to get the question repeated. Can you repeat the question again?
Yes, sir. Actually, the method of people selection, that appraiser selection, if 100 people is there, randomly I pick 3 people. Is that method right or wrong? Why? Because if I have 100 people, every people can't able to measure in a consistent manner. So that's my
One
question.
second.
Why?
Please listen.
Yes, sir.
Carefully looking at your questions is a completely different question now. You are randomly selecting your people for inspecting. You should not do that. Understood?
Yes,
Will I
sir.
go for a tour randomly? I will know about the program, who is the organizer, where are they going, how many days, all these things I will know. Then only I will join for a tour program. Yes or no?
Yes, sir.
So you have to select the people first of all properly and give training and then only use them.
Okay,
Yeah.
sir. Now I understood.
So
Now
that
I
is one
understood.
question, separate question. Now coming to the
Okay.
question of selection of items for study, selection of sample.
Samples. Yes.
Selection of people means selection of operators for selecting, right?
Select. Yes.
The sample.
Yes, sir.
But here the question of selecting the sample comes means the sample should be random. The sample should not be biased. Like for
Biased.
example, if Gopal Sivakumar gives me a task to find out the performance of this group, I should not keep asking only Satish Kumar and Varan. I should also ask one Chandini, one Kishore, and one Edil. Yes or no?
Yes,
This
sir.
is what is random. One person from the first row, one person from the second row, one person third row, or one person from the mediocre people, one from the brilliant people, one person from the average people. This is what is called randomly selecting. See, the object should not know whether he is being selected or not. Everybody should have equal chance of being selected. That is what the randomness means. Understand?
Understood, sir.
The democratic way of selecting the sample is called randomness. Right?
Random.
And the second thing is, you should cover the whole range. You
Yes.
should cover
As
the
per the
whole
customer,
range.
customer spec, I need to cover.
Yes, customer spec, complete range, just because what he wants, only that particular portion. Only I'm, triplicane area, only I'm giving good water. You are not giving good water to Gopal Sivakumar area. That is bad, no? Right?
Yes,
You need vote from me and vote from them also. Right?
Yes.
So the randomness is there, coverage is there, and then so many conditions are there. We will see it later. No? Sampling technique is a separate topic. We will discuss it in detail later on. Thank you very much.
Oh,
Very good.
thank you.
So,
Thank you. Thank you.
so we have samples selected, and then we have the appraisers, and we want the appraisers to collect the data multiple times. This is known as replication. Replication is repeating the same experiment with some time interval, right? Replicating the same experiment with some time interval, and we expect the replicated readings to be close to each other. If the replicated readings are close to each other, then repeatability error is minimal. Tell me, if I have so many readings close to each other, what will be the variation? Variation will be less or high?
Less, sir.
Less. If the variation is less, then the error is less.
Yes, sir. We can achieve
So
the less than 10.
somehow you should be able to measure the variation now. You measure the repeatability error, you measure the reproducibility error. You measure the repeatability error, you measure the reproducibility error, right? And the variation in the readings of the same appraiser can help you to understand the repeatability error committed by the particular appraiser. Am I right?
Yes, sir.
Suppose if I use Satish Kumar to collect data, a particular data 10 times, and he gives me 10 different readings. Now the variation in those 10 readings is a reflection of the repeatability error committed by Satish Kumar.
Yes, sir.
If he is a perfect appraiser, he gets me all 10 readings exactly same, then the variation is 0. That means repeatability error is 0. So all that I need to do to get an estimate of the repeatability error from any appraiser is measure the variation. Now, what are the ways you have studied to measure the variation? Do you know any particular method to measure the variation? Range is a measure of variation.
Minimum and the maximum.
Standard range is a measure of variation. Standard deviation is a measure of variation. What is range? Maximum value minus minimum value.
Yes, minimum value.
Statistically, there is a relationship. Range equal to 6 times sigma. So instead of measuring the range, you can simply, go for 6 sigma. 6 sigma is an estimate of the error committed by a particular appraiser. Am I right?
Yes, sir.
3 sigma on the right side, 3 sigma on the left side,
Well,
maximum minus minimum, range, which is equal to 6 sigma. So collect the reading or separate the readings given by a particular appraiser, calculate a 6 sigma out of it. That will be the estimate of repeatability error that can come from the particular appraiser. Do you understand?
yes, sir.
Separate the readings given by a particular appraiser. You calculate 6 sigma out of it. That is an estimate, please note, because we are only simulating. We have not done the actual data collection. Actual data collection can go on for 30 days, but simulation can be completed in just 1 day. So it's only an estimate. The more cautious and well-planned you are, your estimate can be close to reality. So now I taught you a particular way by which you can get an estimate of the repeatability error committed by each appraiser. Now I'll tell you another way. Imagine 10 readings Satish Kumar has produced, another 10 readings Saravanan has produced, another 10 reading Warren has produced, another 10 reading Vijayan has produced. Now there are 4 appraisers, all of them measuring the same part 10 times. And now Satish reading available, Saravanan reading available, Vijay reading available, Warren reading available. Now the variation within any of the appraiser is repeatability error. We already discussed. Now, since all of them measured the same part, same characteristics, I expect them to agree to each other. Whatever reading Satish has given, Saravanan should also give the same. Vijayan should also give the same. Warren should also give the same. If this is not happening, they have misunderstanding. They have, their own understanding for the same work they are doing, which is definitely an evidence of, inconsistency. So how can I now compare? Now I calculate average from the Satish reading. I calculate average from Saravanan reading. I calculate average from Vijay reading. I calculate average from Warren's reading. All these 4 averages should be close to each other to conclude that they are consistent as a team. If the averages are not close to each other, the degree of inconsistency or the amount of variation I see with the averages is a reflection of the reproducibility error.
Instrument error.
Clear, all of you?
Yes, sir.
So each measurement system reading is averaged, and average of one measurement system is compared against average of the other measurement system, or other way, the average of one appraiser is compared against average of other appraiser. Suppose if I have 4 averages, or let's say, any number of averages, let's say 10 averages. Now, can you calculate a standard deviation of all those averages? If there are 4 averages, or let's say 10 averages, because you involved 10 appraisers, there will be 10 averages. Can you calculate a standard deviation out of it?
Yeah, we can.
Can you calculate 6 times sigma there? That is an estimate of the reproducibility error. If you have 10 averages, with the 10 values, you can calculate range, or you can calculate 6 sigma.
Yeah.
The sigma calculated from the averages is normally called as standard error, not standard deviation. Another important understanding for all of you. The standard deviation calculated using the average of the data points. See, standard deviation of the average is different from standard deviation of all the data, isn't it? Standard deviation of all the data is different. If I involve 4 people, each person brings 10 data, total number of data is 40. Am I right?
Yes, sir.
But if I have 4 people, each person bringing 10 data, I can calculate average for each of the appraiser. Then finally, I will have only 4 averages.
Correct.
With these 4 averages, if I calculate a standard deviation, that is known as standard error. So standard error can help me to get an estimate of the reproducibility error. And standard deviation of each appraiser's data can help me to get an estimate of repeatability error. Right? See, that is from the discussion itself, you could understand we are diving deeper, and then the the procedure seems to be a little complex to conclude about the gauge. I mean, to calculate the gauge R&R. Yes or no?
Yeah.
You doing all of this procedure manually will definitely be very, very laborious and tedious. And that's why it is recommended to use a template or Minitab software for the Gage R&R study. All right. So now I think you are now feeling confident that you can get an estimate of the repeatability error. You can get an estimate of the reproducibility error, because I have shown you the direction. You go in this manner, you will be able to get it. But then all the formulas and calculation, I don't want any of you to worry right now. Leave that job to a template or to a software like Minitab. Right? And then once you master this, once you feel comfortable with this procedure, if you are actually going for a Gage R&R study in a project, and then you wanted to have a look at the formula, you wanted to understand yourself, you want to calculate manually, yes, all will be possible. Otherwise, it might unnecessarily, confuse you to a greater level. So I'm not going to do that. So now that we know there is a way to get an estimate of repeatability error, there is a way to get an estimate of reproducibility error. If I combine them, what is the name of the combined error? Repeatability error plus reproducibility error. What is it known as?
Gage R&R.
Repeatability error. What is
Precision
that?
error.
Very good.
Precision error.
Careful observation. Yes, this
Yeah.
is known as precision error. And now this precision error should be compared against customer provided tolerance. Precision divided by tolerance. Now I get a ratio. Precision tolerance ratio. Convert that into percentage. So that means you have to multiply by 100. Now, when you convert that into percentage, that is known as Gage R&R. This Gage R&R must be less than 10%. If the Gage R&R is less than 10%, measurement system is acceptable. If it is 10 to 30%, conditionally acceptable. 10 to 30% conditionally acceptable. What is that condition? If the customer has given you a very liberal tolerance, then only the second condition you can choose. 10 to 30%. The Gage R&R is also okay. Only if you know the customer has given you a very liberal tolerance, but your process is highly capable. But in any case, Gage R&R of more than 30% is unacceptable. Measurement system should not be used for data collection. This is called Gage R&R study. Yes, Satish Kumar, what's your question?
Sir, actually, for the appraiser selection, you have clearly mentioned how to select the appraiser. For the particular dimension, which instrument we need to select? Is that any method to select the instrument, or any other thing is there, sir?
Yeah, when you are
Because
selecting the
some
instrument,
tolerance I can use vernier.
when you are selecting the instrument, the instrument, yes, it should be calibrated, it should be maintained well, and over and above, look at the resolution. Look at the resolution. Resolution means the least count. Resolution means least count. If the Gage R&R itself is 0.1, if the Gage R&R requirement itself is 0.1, then the least count must be
0.1.
much lower than that. Much lower than that, right? So you must have an understanding about the term least count or the resolution.
So
Just by looking at the resolution, you could see if the resolution is weak, then what happen? Unnecessary rounding of the data will happen. Yes or no?
Yes, sir.
If the data is getting rounded, that's how the error is getting accumulated. So it will add up to the Gage R&R value. So these things have to be understood. Yes, RK sir, you can add.
Please note, there are certain practical aspects also involved in these things. We should not go only by theory and things like that, no? Like I follow a resolution, particular accuracy. I'm using an instrument and I'm making a ringer. I am making a shaft which should go inside the ring, right? The hub.
Ring.
And that is being made in some other place. Then can I tell him I'm using this gauge, use the same gauge? People say no. I did a Lloyd's inspection, third-party inspection by Lloyd's. Right? He was asking me the same questions. So we were making parts for hydraulic components, right? Hydraulic component
Yes, sir.
turbines, turbine parts, blades, and there's so many things, rotator.
Yes, wind turbine related.
Yeah. Turbine blades are all very big, no? It will be height.
Yes, sir.
The size
Yes.
will be my height, right?
Yes, sir.
Now, he was telling me, how do you ensure that these two matches there? One is made at Baroda, one is made at Chennai.
China.
And you know what he said? What is it you are using? He's not bothered about my instrument, what instrument and all. What is the instrument you are using? Do you have a stamp on the instrument? Are you going to use the same tape? If I'm using the tape, the same tape only I should take and
Similar
use that to measure that. Right? Not that I'm using the same gauge there, different gauge with the same resolution and all. Their resolutions, even if there is an error in the resolutions, my job is completed because there will be no error because I'm using the same tape with the same stamp. Yes or no? Right?
Yes, sir.
And similarly, the material also, raw material, the moment I cut out the material and then use it, then how will I ensure that that is the material allowed for that project? So I will have to take out the material and put the stamp on the remaining raw material and then only take it out for fabrication. So there are certain documentation also is involved there in maintaining the, maintaining the system. Right? Thank you very much.
Sir,
All right.
actually,
I
in
think,
this, sir,
yeah.
In this, that 99.5 is the lowest spec, 100.5 is a upper spec. Actually, in that time, can I use a vernier or micrometer or height gauge? Which instrument is suitable for that measurement?
Once again, no. You are asking a funny question. I'll tell you. If the 100.5, 99 point, what you say is kilometer, use a tape. If it is micrometer, use a vernier gauge. Understood? So the question will have to be very properly questioned, right? Understood? You are merely seeing the numbers, but the unit also is metric also is important. Is it in kilometers or meters or kg or grams or milligrams? Okay.
Based on the unit, we need to select the instrument.
Yeah. See, lower the value, the resolution, becomes, very important. The least count has to be, as small as possible.
Okay.
The smaller the best. That is the rule. The smaller the best. Yeah.
Best. Okay.
All right. So now,
Thank you.
now what we do is I will take you through a live exercise so that you all will get a feel of how repeatability error is getting accumulated, how reproducibility error is getting accumulated, and then I will show you a sample data collection, data collected, and then I'll put those data in Minitab, and then Minitab will generate a report out of it. The report will clearly tell you what is the quantum of Gage R&R value. You just have to check whether it is below 10% or 10 to 30 or more than 30, and accordingly you can take a call whether to accept the measurement system or conditionally accept the measurement system or reject the measurement system. And also with the advantage of collecting the data is not just to get an estimate of the Gage R&R value. Using the data, you can generate some graphs and try to figure out the root of the problem. If you involved 4 people, Satish, Saravanan, Vijayan, and Warren, and who actually contributed to more error? Whether it is, Saravanan is poorly repeatable or Vijayan is poorly repeatable, or if there is a problem with the reproducibility, who is differing from others? These kind of questions, can get answered by visualizing the data with the form of useful graph. Sometimes it is bar chart, sometimes it is control chart, sometimes it is, a box plot. You can use different graphs and then find out the root cause. And finding the root cause can allow you to improve your measurement system. Existing measurement system itself can be improved, and then you can go for a collection of the data. You don't have to replace the measurement system. Otherwise, you may have to replace the measurement system. All right, so let's have a small exercise now to feel how the error will populate, understand the repeatability error and reproducibility error in a live manner. Okay,